I haven't checked with Rick on the computer competition teams, but again, we're hopefully sending a team to DigiKey for the competition this year, and he's hoping to get maybe another team or two together with some students to practice for other competitions. So I technically I think yesterday was the last day, but again, you can check with Rick. I know he has uh later on, I think tomorrow he has to send in the list to DigiKey there. So if you want to be on the uh programming team, go to get DigiKey. That's a fun just so basically well you go there the night before. DigiKey puts you up at a hotel, feeds you, and then you have a day of competition. Well, till like 3 o'clock in the afternoon, you come home after that. So it's a fun competition for that. So, uh, okay, so let's talk about our schedule here. So we're starting Unit 4. I will kind of warn you for the first 3 units, I know there's a lot of setup with Visual Studio and GitHub and all that stuff. So we try to go kind of a little slow and not cover that much material. But now we're in Unit 4. We're going to kind of pick up the progress and hopefully be covering a little bit more material every week. What does that mean? So it means a couple things. We'll be we'll be doing our normal text, but we'll be introducing a new text on microservices today and start using that. And like for the assignments, I want you to be doing 2 posts every week from now on. Often you can post one of your own posts and then reply to someone's posts. With a reply, I want you to provide an additional example or resource or something like that. I don't want a reply that says, "Oh, that's cool." There, you can reply to other people and say that's cool, but that doesn't actually count as an official reply. So you can reply to as many people you want and just give them a smiley emoji or whatever you want. But we want you to do one meaningful reply, or 2 posts of some sort here. We'll do the learning activity in class on Thursday and walk through that here. So, and then the assignment is a worksheet on microservice apps to get you started in that area. And we'll start talking about that a little bit today. Today at 11, so in an hour, we have a guest speaker. Matt Haugen is joining us from Target here. He's been working at Target for like 8 years. He worked at Apple for a couple of years before that in California, and then worked a couple places. So he'll give you a little history of him. I'm trying to remember when he graduated in 2007. So he's really old, I guess, apparently. Didn't seem that long ago, but apparently that's longer ago than I thought. So Matt will talk to us. Hopefully he'll jump on Zoom at 11 for us. Okay. So let's just talk about this first. I'm going to go in this learning resource. And I'm going to do a lot of what's in this video, but just walk you through. The video is kind of old, and so we'll kind of do some updates on it, but it's actually still quite pertinent. So we'll basically try to go through the material that's in this video in class today. So we're going to look at, again, part 1 of the text was Scrum and Kanban. And so now we're going in part 2, we're actually getting into some of this coding stuff. And we're going to start with dependencies and layering and looking at that. And this chapter really introduces a lot of stuff that's in the later chapters. So we'll just do brief overviews of a lot of stuff. And that'll be stuff that'll be covered in a whole chapter later on here. But it does kind of set a good framework. So we'll spend more time on the first part of this chapter, talking about some of the framing of this stuff first. So again, it's talking about dependencies in our code. And you might see this diagram here and think this is kind of a client-server kind of dependency here, but it's actually a client and a service here. And this isn't like a web client-server, like a website, or a web browser talking to a website kind of dependency. This is where in your code, you might use some other parts of your code or another object or another library or things like that. And we want to try to minimize these dependencies that are in our code for that. And they create a simple console example, talks you through create a console example and showing that. And this is, again, using some old Visual Studio code. So I thought we'd just redo this here. So I'm going to walk through it. You can do it at the same time, or you can just watch. We're just going to do what's in the textbook, basically, here. And some of this code I'm going to paste in from here, because I'm pasting slightly modified versions of what's in the textbook here. So I'm going to follow textbook. I'm going to go to Visual Studio. I'm going to do a new project. And I'm going to do a console project. And again, the way it looks here and here has been changed, but I'm going to do a console project, give it some names. So this will be my, unit 4 sample dependencies app or something like that. And one thing it wants you to do is just see some of the dependencies in the Solution Explorer here. And we can see that. So if I have this open, here's my app and here's my program here. And then there's a little group up here called dependencies. If I look up there, there are different ones. There's framework, and inside framework is the .NET Core. And there's a bunch of dependencies in there. .NET brings in a lot of libraries here, system libraries, collections, the data libraries here, diagnostics, the IO libraries, the file systems, the .NET stuff, security stuff, threading, all this stuff is brought in so these are all libraries that are brought in by this .NET architecture. And they're all generally grouped under the .NET framework, so which is nice because you just generally have to have that one framework. And again, that framework, that core.NET, is now available in Mac, Windows, or Linux for this. I'm going to modify, again, I don't know, they've updated this console write me or hello world kind of template. So it's not even a full program now. I'm going to go over in here and just grab this main program here. I'm actually going to grab the class too. Do I have my namespace? I don't even have a namespace here. So I'm going to grab this whole thing, I think, here. And replace this with that here. Right now, I'm not going to be doing anything with print services, so I'm going to just skip that for now and I just need a write line that says like enter a key to quit, and then I'm going to do a read key. So that'll keep the program running, and we want to keep the program running so we can see what all the things are that runs when we run this simple program. And again, in the book, it talks about that. So here's the simple code that it suggests you have. And then it says run it and look in your debug windows. Now, where it says the look has been changed, so let's look and see where that actually is. So again, if I run this app, it'll open up a console window. And it's going to say press any key to quit, and it's going to keep running. And that's important for this to be here running so that I can see some of the things. So again, there's some diagnostic stuff here. But under debug, I can actually see some of the stuff that's running here. Under debug windows, now I'm trying to remember which one I want here. I thought it was resources. I think it's modules down here. I'm going to go to debug, yeah. Debug Windows modules, and it's going to show me all the things that this started up. So it started up a console DLL library, but it all, which makes sense with console app, but it's also started a couple threading libraries, a couple security libraries, a runtime loader here, collections here that's like manages if we have arrays or all that sort of stuff. So it starts up all this stuff, including the DLL for my main program here, that unit 4 sample DLL here. So these are all what are called DLLs. These are what we're kind of compiling into these dynamic link libraries. And I just want to see that programs, even simple programs, have lots of dependencies under them, lots of things that are running, lots of libraries that are built into these. And as we add more programs, we don't want to add more dependencies to this. So again, we just want to see that there's all these things running in the background when we run this one thing. Okay, now I can quit this thing. One thing I suggest you do is I find, like, if you read through this text, it often just, I find it doesn't make sense to students the first time you read through it. You might want to read or scan through it. And when you come to class like this, we'll walk through it and we'll build some of this code. We'll try some of this code out and put it, try to explain what it does. And then I think if you read the text afterwards, it'll make more sense once you've kind of played with it a little bit. So that's what I suggest. So that's why we're kind of going through this today. So let's see how we can break up code in different ways for this. So let's talk about a couple ways of organizing code in our projects. The first way is just to put code into folders. So right now I have a solution, and then inside that I have a project here. Within my project, I can create folders. I can say add folders. So, and maybe I want a folder for print stuff, print services. I'm going to delete this in just a second, put it somewhere else. So I'll just tell you, I'm going to just show you could put it here. And then you could make a file within this. I could make a new class. Within this. And again, we'll often do this. We'll have folders within our project, and we'll have different things. And then you'll see that the namespace will refer to those folders. So like this isn't in a folder, so the namespace is just simple dependencies here. But this is in a folder, so the namespace is a unit 4 dependencies that print services there. And so usually we use the solution as our main namespace, and then the dot, and then the folder as a subsequent namespace for this. One of the problems is that now if you add more and more folders and more files here, and again, we will, like, tomorrow or Thursday, we'll create an app that'll have 4 folders, and within those folders there'll be some subfolders, and then with them there'll probably be at least a dozen C# files. And we'll just create that in one day here. So again, it's not hard in a project like this to get a lot of stuff. The problem, and you need to organize it in folders to keep track of it all generally. But the problem is when we build this, when we compile this, so if I say compile this, it has to compile all of this code here. And if there's a problem, an error with one of these things, so like in print services, if I have an error of some sort in there, it's going to keep the whole project from compiling here because it's in one of these services. So if I try to build this, it won't build, even though my main program doesn't have any errors and doesn't use print services at all, it won't build because of that. So an error in one of these folders will keep the whole thing from building because again, it's going to try to build everything. And also it can take a long time to build these things. Sometimes we'll build these or run these and it takes a while to do that here. Don't think we're at the point where I used to compile and then get up and walk away from my desk and go do something, go get coffee, go visit a friend or whatever, and come back 15 minutes to see if the compile was done. I don't think we're quite there, but still, it can take a while to do these compiles or builds. So rather than doing it this way, I'm going to delete, and again, we will do it somewhat this way, but one thing we will do, let me delete that, is that we're going to make multiple projects for this and put certain code into different projects. That's one way of setting this up. So I'm going to, rather than going in on the project level and doing a new folder, I'm going to go to the solution level and say new project here. So I'm at the solution and I'm going, where's my new running? I'm just trying to figure out why. Oh yeah, I have to add and then new project. So I'm going to go down to add new project. And then again, it'll bring up all these things. I'm going to look for a library. So I'm just going to switch this, make sure this is at C# and do a library here. And the first one is just a class library. And this is what I'm going to do is a class library in C#. So I'm going to choose that as my project, a C# class library. And so I'm going to go back here. This is where we're going to do our print services. So our project is going to be our print services here. So I'm just going to call it like message print services or something like that. Okay. So I'm going to create a new project here. So now I have two projects, this message printer and this other thing. I'm going to add a class in here, a new class for this. And I'm going to actually go back to this code and do this. I'm going to add a message print services class for this. So again, it created a default class one. I'm just going to make another class, add class, add new item class or add class, and call it message print services. Here it is. And again, I don't really need to do anything to that. I'm just going to have a message called print message and say hello here. So we're just going to add a little hello thing. And again, this would maybe print out messages that are that you'd send or maybe to the accounts or whatever. This would be some separate method that you'd want or library of services you need in your program for this. Now, let's talk about how we link these two things together here. So I have a class. I'm gonna make it's listed as an internal class. I'm gonna need it to be a public class. So I'm gonna make sure it says public class there because I'm gonna use this outside of this library. So public class here. So I want to access this from my main program here. So that's what this kind of does is I want to access this print service. I want to create a new print services object. So what was it called? My class was called a message print services. So whatever your class is called, again, I'm just going to replace this here. We're going to do a message print services, call it something, give it a variable of some sign, print server equals, and then we're going to instantiate it, new message print server, or whatever your thing is called. There. And then once we have that defined, we should be able to call the print message method inside that. So whatever this is called, we should be able to just say, print that message. And that should just say hello world. A lot of work to say hello world, I know. Okay, so what I want to get at is how do we connect this library to my main project's code here? You see these are highlighted. It can't find message print services because it's not in the same namespace here. And there isn't a good solution. Quick actions says use implicit type, generate a new file. You know, it's not saying just do an include here. So, but you might think, well, we just have to do a using here. So above this here, we just have to say using and what is the message printer namespace using message printer. And it should find that and use that, this message printer library over here, namespace here. But again, it's not finding that here either. And so what we have to do is add to our dependencies here. In this project, we have to say what other projects or libraries it's using here. So under dependencies here, I have to say add a project reference here. So I'm going to go to dependencies on this project, and I'm going to add project reference. Now there's a bunch of different libraries out there, and sometimes we'll have to add these. You know, maybe you're referencing some JSON parser or some other things. So there's lots of different libraries out here, but those are all pre-built ones by here. But under project, there's just one message printer. So we want to say include the message printer library in this one. So once we do that, now our using message printer is not, it does not show an error, it finds it, and it should find the message printing services down here. So we've added that to our library, our project message printer. So that's do is add this whole library, this whole separate project here to this one as a dependency. And then when we run this, it should say hello world. Well, that was exciting to say hello world. And then press any key to quit. So this was the old way of building applications in Windows with dynamic link libraries. And we're going to kind of contrast that with microservices and how microservices work here. So microservices really weren't a big thing when this textbook was last published. And so that's why we're going to add a separate microservices text to kind of supplement this. I'd say 70-80% of this text is still very current and good. But again, some of this like DLL, and again, one of the reasons you go, wow, why are you even teaching us this, Tom? Well, to tell you the truth, lots of companies are still running this architecture, still running with dynamic link libraries and building things this way. So this is still, I mean, there are still companies that are still running on mainframes and old systems. So this is relatively new even for some companies here. So you should be aware of how this works. So what happens is that message printer compiles into a DLL, a dynamic link library, and that DLL is brought in here. And I don't know if you've ever had to bring in DLLs from other places or import libraries, but it's a common thing if you bring in features to bring in a DLL library and maybe include it in your project or include it in the Windows systems folder so it can be accessed by multiple places here. Okay, I'm going back to the textbook. So that's what they're talking about here. They're trying to set up this message printer. And again, you might want to now go through and read this and see if you can understand this a little better. And they're talking about the message printer DLL assembly has been loaded and how that works here. And what we get into is what these dependencies here and how these references. I'm not going to go into these references and how we reference dependencies. These days, you can just add dependencies. That's what we did there, and we don't have to worry about that. Again, they also talk about other dependencies, third-party dependencies you can bring in. So maybe you know, like for managing a camera or for doing some advanced vision or image work, you might bring in libraries and things like that for that. We often try to model these dependencies with this graph. Trying to get this to be on the screen a little better. That's not working. Okay. So here's our graph. And I mean, A would be like our main program, and then B would be something it depends on, or C would be something that depends on. So like in this case, we're dependent on our message printer. So A would be our main program, and this is our message printer library. And we'd have these different things. We often include arrows in here showing that this depends on this depends on this, and this depends on this here. These dependencies get very complicated, and there's a whole package manager systems that run. There's like a number of package manager systems that run on different things. We use a package management system called NuGet on here. We'll talk about NuGet a little later. Question?
Yeah, I just want to ask you, like, this dependence, which was showing, so it's like A to B. This dependence can also impact the
Can also impact what?
like on that graph. Yes, so our only dependent was only C, right? So there's also an R going to B. So it also should then B can also add a member right?
Yes, right. So yeah, B can have, and this would be like, I would consider like B maybe to be the .NET or the ASP kind of package, and then that has a lot of other packages that are dependent on it here. And you may have seen this in places where you've had to try to like install a library. Like Python, we see this a lot in Python packages. But if you've worked in like Linux systems, there's a package manager there. There's a couple different package managers there, and you can install package. And what it does then is that if you install some package like B here, it will often install a dozen other packages that are dependent on it that it needs to build. We get into something called, it used to be called DLL hell. And so people just call it package problems where you might bring in a package and it requires a certain version of another package. It's like version 1 of this package, but your package also requires another package like D, and that requires version 2 of package F. So you have this problem where B requires version 1 and D requires version 2. And so you can't, I've had problems where you just can't bring in these packages because of the version problems and compatibility. So there are a whole system to try to manage these packages and bring in the right versions of them. So we're not going to get too much into that. And again, I'm not going to talk too much about cyclic dependencies and some problems that that will cause here. So we want to look at managing patterns for this and how we can try to set this up so we don't have as many patterns, or what we'll be looking in this class is a lot of patterns, ways of structuring our code, and then some anti-patterns, ways of structuring our code that aren't very good here. And we'll try to suggest ways, look at ways of structuring our code and where do we put our classes and how do our classes depend on each other that have good, it's a good method, a good pattern for how we'd set up our code. So a lot of this course is set up on these patterns and talking about what are good patterns for structuring our code. And here's a couple of the big ones. One of them is interfaces. We'll be using interfaces a lot and talking a lot about interfaces. In fact, the next chapter is all, I think it's the next chapter is all on interfaces. Yeah, interface design patterns is all. So again, we'll be talking a lot about, oops, I didn't want to do that. I'm going to do this. Okay. The book will talk in various spots about code smell. And again, they're just trying to get at the idea that some code just doesn't work very well. Here, their definition of that is that the code smells bad here. It's just the way it's set up, and it's kind of an anti-pattern. It's just a phrase for that. So we're going to look at one example here on how we can set up dependencies among our project here. So we're going to do an account controller. And watch our time today. And set up this. So I'm going to go through this relatively fast, but I think it's good to see it in the code here. So I'm going to create inside my main project here. I don't need dependencies. I'm going to create a folder add a folder for account service, or yeah. I'm just going to call counts, I think. Yeah. And inside that, I'm going to make a class for the account controller here. Add a class, account controller. And we're going to put this code in there. I'm going to switch over to this code here, which is a little updated version of it. So I'm going to grab this code from here and paste it in my account controller class for this. Oh yeah, this already has the security here. So I guess that's the final version. So we're going to then add a security service to this. So again, we're saying our account controller is going to create a new security service. And eventually we're going to do it through an interface. But when we first do this, we're going to just do it with how we would instantiate an object here. So we're going to have security service up here, object, and then we're just going to do create a new security service object for this. So before I want to just say create a new or define a security service here, and in the constructor we're going to say new for this. Now, one thing we're going to see is that we are going to want to avoid where we create new objects in classes. In general, this is going to be an anti-pattern. Whenever we see a class creating another class, we're going to say, ooh, that smells bad. Why? As far as testing and stuff, it is hard. It sets a hard dependency in this class. So if we were to run tests, unit tests on this here, we would have to include this object in our unit test. We couldn't just test this account controller by itself. We'd have to include this security stuff with it. So we're going to wait and go, well, how do you even do it if we can't create new objects? And we're going to look at that. We're going to be passing in these objects often to the constructor rather than creating them in the constructor. So we'll pass them in here, and then we'll do all of our news, create all our objects somewhere else in one central location and just kind of pass them around where needed, is a more common structure of setting this up here. So let's try to do this. I'm going to create, so I need a security services class. Let's see, can I just create a new one? Generate a security service class in a new file. I want to do that. It will add security services here. I'm going to add some code to that. Here's my security services folder. It's going to use a user repository. So again, it's going to create a new user repository here. So I need a new user repository class and a new user class. So I'm just going to create these files, and I'm going to create a new user file also. And here's some code. We're not going to really do anything in our user repository. What that would have is a list of all of our users here, and we'd be able to get a user by an ID for this. So we press our user ID and it would go out and get the user. We're just going to throw an exception and not do that now. That's what it would do. In users, again, we would be able to do things like change the user's password or something like that. So under a user, we're just going to have one class, change the user password. Okay, so users should, if I put in this code and user repository, should not have any errors in them. They should be happy. Now user services, security services should be looking good. And for this, I'm going to close some of these other classes here. Okay, so I'm going to go back. So I got this basic setup where I've got an account controller. I've got and it uses security services to change a password. Security services has to go to the user repository to get a user, gets the user, and then tells the user to change the password here. So all these things are linked together. Account controller calls security services calls the user repository, and it uses that to get a user for this. Now this talks about some of the problems with this code here. Account controller is forever dependent on security services and user repository. You can't test or do anything with account controller without a user repository and a security service here. And it's very difficult to unit test here. If we were trying to write a unit test for account controller here, it'd be very hard to do that because it needs it creates a security service. So we need to have security service code in here also. And security services also uses the user repository and the user stuff. So account controller can't be tested without those, with all of these. You can't just write a unit test on this one class. You'd have to basically have all of this code in here for this. Now, eventually we'll look at ways to stub out or put in a, rather than using this security service, just a proxy or a dummy security service that we can use for testing, unit testing. And we can't do that with this setup, the way this is set up here. So again, we talk about our chain of dependencies and how we might set this up for this. Now, there might also be other services here. I'm just going to paste this code. I'm going to comment that out in a sec, but it just illustrates this point. In secure service here, we could be, oh, it's actually already here. We could be calling this code here, opening up a session factory and getting the information from a session factory here. Now, you might not recognize this code, but if you worked a lot with a library called Hibernate, this is Hibernate code, and this we'd have to be saying using Hibernate up here. And this is, once you bring in Hibernate and that whole Hibernate code library for database access and that sort of stuff, it brings in a lot of stuff. So this one line and using this session management tool in here would make this depend on lots of other things. It would be kind of like here, we had our little thing that bring in this and it'd bring in a bunch of other dependencies related to that for this. So again, we might have security services might bring a lot of other dependencies. Now I don't have Hibernate installed, so we're not gonna worry. I'm just gonna comment that out for now, so that we can at least talk. And again, it talks about testability. We'll be doing, I don't know if you've done much unit testing, but we'll be talking a fair amount about unit testing. I wonder if Matt will talk about unit test. We should ask Matt if he does any unit testing today for that. So here. But unit testing is critical. In most development environments, you write code, you write unit tests, you have to run the unit tests, they all have to pass before you can say your code is complete here. And then we have to look at how the classes are related to each other or how they're working with each other here. Let's just look at this. I'm going to look at the user security services. So security services is going to let us change a password. So how is it going to do that? We're giving we have a user ID here. Let's see. So what we're doing is we are in security services, we are creating a user repository and we're then using that to get a user based on the user ID. And then we're having that user and we're saying change password here for that. So does that all have to be in here? And one of the questions is like with users, in this example, do you need to have that, do you need to know and access the user object, or can you just pass around the user ID there? We want to minimize which classes know what a user object is and have access to a whole user object. Instead, it'd be better just to pass around a user ID and just minimize where the actual user interactions take place here. And that's what they talk about here is doing this code. In fact, I thought, yeah, originally what we did is we had this in account controller. So what we could have, this isn't that bad a way, but we could have had this all in account controller. So Another way of setting this up would have been to move this into account controller under change password. So here we could have had the account controller create a user and tell the user to change a password. But we wouldn't need the account controller to do all that. We could get rid of that. We could just move that code into security services and have security services access a user. So again, one of the things we look at is like with a user and any object like that, when do you need to actually access that user? Can you push that to a different spot and just pass a user ID or some reference to that user around for this? The last thing we're going to look at, and I'm actually going to, I think, save this. Well, let's just do this one little part, and we'll do more, is how to access through an interface here. So one of the things we see here is that account controller creates an object of security services. And one of the ways we're going to try to break that connection between account controller and security services is to put an interface between them here. And again, we'll get more in the interfaces, but let's just look at this as one of our first examples. So between account controller and security services, account controller creates a security service object. We're going to have it do that through an interface. So how do we do that? We're going to create an interface, add a new item. Oh, if I say new class, yeah, if I say add class, I can just say interface as the class. Now, interfaces generally begin with a capital I and then have the name. So we're going to call this I security services, or interface for security services. So an interface will be kind of define the paths or the connections between one object to the other. So right now, account controllers here, it creates a new security services and it calls change password in there. So the only thing right now that we need in the interface is change password. In fact, that's the only thing this knows how to do. So I'm just going to grab this the change password definition and paste that into security services. So we're going to say that anything that provides security services has to provide a change password method. Right, for now, that's the only thing that's available. Now, when we do this here, we're going to go to account services and have it use this interface. How do we do that? So when we declare an object, our object is not a security services object. It's an I security service object here for this. So we're going to declare an object of the interface type, not of security services. And then we also need security services to implement that interface. So under internal class security services, we say implement, and that's just colon, and then the interface. It implements that interface. And then it has to make sure it defines the password, and it does. We built it that way. So now we create a new security services, but it's an I through this I security interface. So we have this kind of level of abstraction between these two. And what we'll see on Thursday and throughout this class is that abstraction will let us do some cool stuff. We're going to wait and do Thursday. We're going to do dependency injection on Thursday and look at that. And that's the next step at this. So I'm just going to save this for now. stuff. And again, I think it's again, reason we're doing this is just I think if you read through this code, it doesn't make that much sense the first time. So I think it's good to have me kind of go through it, have a project with it out there, and then now, between now and Thursday, maybe you can read that through that code, and it'll make more sense to you. Okay, so back. Also, there's a whole video that you think, oh, Tom was so exciting. I wish I could hear Tom again. And you can hear old Tom. This is like a 5-year-old video of Tom here. So you can listen to old Tom here if you want. So, okay. Now, and again, so Thursday, we're going to do part 2 of this. And then we'll do the learning activity. I'm just going to bring up this other microservices today because I want to introduce those before Matt gets here. Because if Matt doesn't, I'm sure Matt's going to talk about microservice architecture because he's a web development at Target here. So what we're going to be using is this free online textbook. This is from Microsoft, and so it is, of course, Microsoft bent there. But again, I've tried to look at, I really want an AWS one, but I couldn't find a really good AWS one here that was also free and stuff like this. So we'll be using this microservice architecture. We can read the whole textbook here. There are all the sections are here and stuff. And in fact, I'll link into these sections here. You can also grab the whole PDF. You can download the whole PDF. If you click on this link, it'll download the PDF for you. So if you want to do that, you can. It is just 400 pages, something like that. I'm going to actually just talk about a couple things through this Lumen, which lets me highlight certain sections here. And I don't want to see. Okay. So this is the full PDF. Again, there's instructions. Okay, we're going to be skipping over the first couple sections on introduction to containers or Dockers, at least initially. We might come back to these here. You may remember we did, if you've had system architecture, we talked about Docker and containers a little bit in there, and we'll be doing more with containers in this class for that. So we're going to skip over that. There's also this whole section on what kind of .NET environment you should be doing, and that's now old. We are all using .NET 8, and so this framework versus .NET 7, that's all gone away largely, so we are going to skip that whole chapter. Here, architecting containers and microservice-based applications, that's where we're going to be looking at stuff here. So again, what we're doing is we're running applications in a container, in a Docker container. Every container will have an entry point, and we'll run it in there. Now, if you have an old application that's one big application, we call that a monolithic application, and we can still run this in a container. And a lot of companies are doing this. You don't want to run it on your own hardware. You're going to run it on a virtual machine. But rather than running on a virtual machine, you might want to run it on a container there. So we will often take one of these single monolithically deployed web applications and deploy it as a container here. Now, one of the things that having containers does help is that we can scale this. If our web traffic kicks up, we can run multiple containers on multiple servers to manage this here. So we take our entire application with all the different components and put it all together in one container. So this is not what we'll be learning how to do. This is the old way. So if you had a big application, wanted to try to virtualize it, this is one way of doing it for this. So, and then once companies start doing this, then they usually start pulling things off into different subservices and slowly moving to microservice applications. So again, right now we might have this is a big server with applications inside of it, all on one container. So that's the not good way of doing it. So I'm going to skip over a bunch of this stuff here. And so there's something called the service oriented architecture, SAO, which is again trying to have your app broke up into different services. And for a while, this was kind of done a lot, but it had some problems. And we are now looking at microservice architecture, which again is kind of like that, but on steroids. We just have a lot more. It's kind of like service architecture done the right way, is how it's often described here. So microservice has better maintainability. We take this big code, it's one monolithic thing, and we break it up into multiple little services. And what's nice is then each Scrum team can be working on their own service, microservice, independent of everyone else. And like we saw earlier, like if we have an error in one project or one code, it would keep the rest of the project from compiling. And also when you build it, you build the whole thing. Here, every microservice runs in its own environment and has just its own code and stuff. So you're kind of isolated from all the other microservices, and you can just work in this one area. You don't have to worry about all the different other areas out there here. And so we'll be looking at this microservice architecture quite a bit and how we can build this and deploy it with Docker here. And Visual Studio has nice support for this structure today and how we build it. So eventually, I'm not going to get to it yet today, but we'll talk about how each microservice has its own domain data. And so that's one of the questions we often ask people when they do this microservice. I'm always considering is, so do you have a separate database in each of your microservices? And how you have to look at how you're going to break up your code and your databases. So you often have different databases. What generally often happens is that you might have a big database initially, or you revision a big database with users and products and orders, and they might be all tied together with keys and foreign keys. You might break those up into separate databases. So you have a database for users, a separate database for products, and a separate database for orders. And then you'll have some special key that's used to tie them together. But because they're in separate databases, you're not doing big queries that combine all that data together at some point. So that's kind of the idea of this microservices. I'm going to want you to delve a little deeper into it here. So for the assignment this week, there's a document that here I want you to make a copy of and work on. And so you just have to go through this worksheet about microservice architectures and paste in the question or the answers in here, pictures and all that stuff, and go through this stuff. So I want you to look at different microservice stuff here to kind of supplement what we'll be doing as far as the textbook goes here. So again, we'll look at this monolithic versus microservices here. We'll look at service-oriented architecture, which the textbook talks about, and what that is, and what other people say about that. We'll talk about scalability. So in this textbook, they talk about scalability a lot. Let's just talk a little bit about that. So, um, I'm just gonna go back here. So one of the problems we have with scalabilities is if we have a monolithic application, one big application, we can try, and all of a sudden our website gets really popular and we want to do it. We can create multiple servers and run this application often on multiple servers here. But then the question comes is if you're running it on multiple servers, how do you scale it properly? Particularly if you have a website, not every part of that website is going to be in high demand there. So, I mean, if you look at a website, what are the most used parts of a website? Probably browsing products. You probably spend more time browsing products than you do commenting or reviewing products. Probably even more time than you do paying for products. So if you have to scale the entire application, uh, you're going to scale things that you don't use that much. Where if you're doing microservices, the idea is that you can scale, you can create more of certain applications than others. So, okay, I'm going to wrap up. So again, you've got to go through this worksheet on microservices this week because it looks like our guest speaker is here.
Yeah, you
Hey,
guys are
Matt, are
talking.
you here? I can't hear. Just wait. Why can't I hear Matt?
Is that better?
That's better.
All right.
I'm going to stop. I was recording this here. I'm going to stop this recording.